I think that is finished. Functions, guys, functions are, again, algebraic expressions who has a rule inside. For example, what is? We have f, the function, it depends on x, and the rule for x is this one, to take a square of it plus x plus c. For example, for quadratic functions I'm talking. Function is always kind of rule, okay? But now here we are not working for functions. We will not study the functions because normally in the program you have been studied the functions. Now here we will start the quadratic functions. What is the difference? In the quadratic equations we had equal to 0, but here in the functions we have y is equal to f of x, and this one is equal to ax squared plus bx plus c. Okay, this is quadratic function. It is equal to y, and functions always we're showing in this way. Y is equal to f of x. This is the general form of functions. Y is equal to f of x, and then after f of x you have the rule. For example, 2x plus 3 is a function also. What is the rule here? You will multiply x by 2 and then add 3. Okay, this is the main logic of functions. Here we will work for quadratic functions, and we know the standard form, the general form of quadratics. It is ax squared plus bx plus c. Okay, this is the definition of quadratic function. Here down you have the graphs of quadratic functions, and we call the graph of quadratic function parabola, guys. The name of this shape is parabola. What is here given? Two cases is given. If you can see, you have them in the book, but to take note what are these elements here is important. Here, the first graph is if your a, the coefficient of x squared, is positive. If your a is positive, your parabola will be upwards, will open upwards. Like this, it will go upwards. And here what we have, the points that the parabola cuts the x-axis are x-intercepts. We call them x-intercepts. They are the points that cuts the x-axis. Look, the parabola cuts the x-axis in this point x1 and in this point x2, and we call them x-intercepts. And the point that cuts the y-axis is called y-intercept. Okay, and this one is the C here. This C is y-intercept always. Your parabola will pass from this point in y-axis. And here you have the axis of symmetry. Do we know what does mean axis of symmetry? Symmetry.
Straight y-axis.
Symmetry, we know what does mean symmetry? When you have a line and in both sides of that line is the same thing. If you will flip, you will get the same. For example, if I will flip this parabola to here, you will have one line. It's the same thing.
Okay, sure, okay.
Okay. And axis of symmetry, from in this point, both sides of the parabola is the same. This part and this part. If you will flip the parabola like this, you will have only one line. Okay. So here, this point is the vertex. We call it vertex. Okay. What is vertex? When your a is positive, the vertex is the lowest value of the function. Here is the lowest value, yes? After less than this one, we don't have here. As you can see, the function, the graph finishes here. And this is the lowest value of the function. When a is negative, the coefficient of x squared is negative, your parabola will be downwards. Like this, okay? Downwards, and the points are the same, x1, x2, c here, as you see in y-axis, and the vertex here, this point is the vertex, and vertex is the highest value of this function, okay? It's the highest value that it can take. Did we understand the elements? After that, I will give you steps how we are finding these points, the values of them. Now I'm telling them their names and for what we are finding them. So when I will say x-intercept, you will understand that it is the points on x-axis, okay? And in that points, our parabola, our graph will pass from x-axis in x-intercepts. Y-intercept is the point on y-axis, and our parabola passes from that point in y-axis, okay? And vertex is the highest point if our parabola is downwards. It is the lowest point if our parabola is upwards. Okay?
It's okay, teacher.
Okay. Then I'm continuing.
Okay.
Now here, there are some questions, and it says sketch the graph of the functions there.
Teacher, can you remove the, how to say, the squares, or they are needed?
It has been to find the points easily, you know.
Oh, okay, teacher, okay.
But let me do like this, maybe it will be better, not to be, oops. If I will do this one, but okay, like this. So this one. Like this, it would be better.
Yes, teacher.
Okay. Now, what we will do, guys, here. Let me take this one. First type of quadratic function is y is equal to ax squared. If you don't have b and c, if you have them 0, how we'll draw the graph of these functions? Here, I have the first one, y is equal to x squared. Always, if you will remember, when we were drawing graphs, we were giving some values. Do you remember? We are giving some values to x, we are finding the y, and then we will join the points that we have found. So let's do that one. I'm giving x values and y will be here. Now, I will start to give from some negative values. When I will give -2, for example, I am choosing this value. It's not important which value you are giving. -2. If x is -2, y will be, what will be y?
4.
4. -2 square will be 4. When I will give -1 to x?
1.
1. When I will give 0?
It will be 0.
It will be 0. If I will continue to give 1, the positive,
1.
it will be 1 again. And 2, it will be 4. As you can see, the values are repeating here. Now, let me find 0 is here. Let's say 1 is here. And -2 is here. Here I have the positive ones. These are x values. And here we'll find the y values. What I have, 0, 1, 2, 3, and 4 here. So first, when x is -2, y is 4. So it is somewhere here. Yes?
Yes, yes.
And when x is -1, y is 1, the other point will be here. When x is 0, y is 0, the third one will be here, and the other one will go here also, and 4 and 2. When you have squared notebook, it is easier to find, to draw them.
Yes, teacher, but when you showed the squares, it was like...
Yes. Now I'm drawing my parabola. Because it is quadratic, because it is second degree, you cannot draw straight lines here like this. Okay, it's not correct because this is second degree function. It has to be parabola. So I will try my best to draw it. It's not seem very well, but you know, it has to be something like this. I hope that you understood my...
Half circle, teacher.
Yes, half circle.
But teacher, only if it is second degree, right?
Yes, yes. Okay, so something like this. If we had the normal green board and the white chalk, I would do my best, but now here I cannot. So did you understand?
Yes, yes.
Now this one is y is equal to x squared. This one has to pass from this point, but I couldn't make it. Something like this it will be, guys. Okay, now...
Teacher, why for x you have written -2, -1, 0, 1?
Can you explain?
As I said, I choose the values.
We choose the values?
Yes.
And you,
For example, you can start with -4. You can give -3 and all different values, like what you want. Why I started with negative, I need also to see in this part how my graph will be in the negative part of x. You know, if I will give only positive values, you will find only this part, this one here. But you will not this part. Because of that, I am giving also negative values to know what will be my graph in the negative part of x. Okay?
So we can write the parabola.
Yes, to draw, to finish all the things. So here, my graph doesn't finish here. It goes till infinity, guys. Okay? It goes till infinity here. Now let's see what is difference between y is equal to x squared and y is equal to 2x squared, how it change. So here, if I will, let me do here better, x and y is equal to 2x squared. Then I will give the same values. When x is equal to -2, what will be y now?
2 times 4, it will be 8.
It will be 8. Yes, and -1?
It will be 2.
It will be 2. And 0?
0.
0.
1?
Again,
1.
2?
And 8.
And 2? 8. Now I will try to draw this one. Where to draw it? I will draw it. I will try to draw it here somewhere.
Teacher, you can do a copy of the previous one or not?
It will take too much time for me. -1, 2, 1, and 2. Now, which values we have here? 0, let's say 1, 2, 3, 4, 5, 6, 7, and let's say this one is 8. And I have 2 here. So when x is -2, y is 8. First point will be here somewhere. When x is -1, y is 2. The second point will be here somewhere. And this one, and it goes like this. So our parabola will be now I don't know how I am drawing this. Okay, so it gets, when the coefficient of x squared is getting bigger, the parabola gets narrower, you know? If it was, for example, here we have a as 1, it's like this. If it was 1/2, you will have here, it will get like more open. You know, when the
bigger the number, the small.
yes, the closer parabola. Okay? If I will find here, we had GeoGebra. I would show you better like this because it will take too much time. Are you writing something?
No, teacher, we will write later.
Like matrix.
Now what?
Teacher, can you go a little bit down?
Yes. What will be when we will have negative coefficients?
Teacher, it will be more far.
But firstly, it will be down.
Down.
Yes.
Yeah. Teacher, it will be the same but downwards.
Now I will try to show you here. Can you see this one?
Teacher,
Yes.
can you go back for a second to take a screenshot?
Okay. I will go back. It's okay?
It's okay, teacher.
No, teacher. Oh, yes,
Okay.
no, okay.
Huh.
Okay.
Let me show you this one. GeoGebra is open. Now I will write first. Look, when it's only x is a straight line, but when you will do x squared, it's a parabola. This is the parabola of x squared. When you have, for example, 2x squared, let me write here, 2x squared, it gets narrower. For example, if I will do greater like 5x squared, look, it gets closer and closer. But for the negative ones, minus x squared will be downwards.
It will be the same but the opposite.
Yes, opposite direction, let's say. Minus, let's do 1/2. So I have here 1/2 x squared. Look how it gets more open. Okay, but only the thing is here, if you can see, all of them passes from the point 0. There is no any x-intercept, different x-intercept or different y-intercept here. When it's your graph is like ax squared, there is no b and c. The x-intercepts and the y-intercept are the same, 0. The parabola passes from the 0 point only. The other parts, it doesn't cut. Okay? Did you understand?
Yes, teacher, but they cannot be 0.
It can be. Y-intercept and x-intercept can be 0. And here, as you can see, it's 0. Y-intercepts and x-intercept, as you can see, it's 0 and 0. Only from the point 0, it is passing. Look, if I will get it closer, the graph continues till the infinity. It goes and goes. There is no any finishing part of it. Okay, did we understand?
Yes, teacher.
This is the y is equal to ax squared graph when you don't have b and c. it passes from 0, and the other part goes to infinity. Only you are finding with these values how much it will be open or close, okay? Now, let's see this one. And this one is the important part, how we're drawing the graph of the normal quadratic function. When you have ax squared plus bx plus c, when you have all of it. There will be lots of steps, guys, and this is very important. I hope that you are listening right now, me.
Yes, teacher.
Okay.
Yes, teacher.
Oh. Now, first step, what we need to find to draw a parabola, we need to find the vertex point. And what I said for the vertex point is the highest or the lowest
point.
value of the function. And here you have formula for vertex point. This is vertex point will show with V, and you have H and K. H is the X ordinate, X coordinate, and K is the Y coordinate of the vertex point. How we are finding H? H is minus B over 2A. You are taking from the quadratic function B and A. And K is f of H. What does it mean? I will show you in a function. For example, we have this one, 2x squared plus x plus 3. I'm writing from my mind, okay? And I need to find the vertex point, h and k. I'm looking for the vertex point. First, I will find h. H is equal to minus b over 2a. I know this formula. So what I will do, minus, what is b?
1.
1.
And what is
And 2 times
2
2.
times 2, 4. So h is minus 1 over 4. To find k, what I will do, f of h it says. What does it mean? Instead of x, I will write h values. So it will be 2 times minus 1 over 4. Oops, my tablet is not okay. Do you understand what I wrote here?
Yes, the function, right?
Yes.
Y is the function, and h is the x of the function.
Yes. So here I have 1 over 4 plus, again, 1 over 4. Instead of x, I'm writing 1 over 4 and plus 3. You will do this operation and you will find k. And it will be 2 times 1 over 16 minus 1 over 4 plus 3. And you will do all these operations and you will find the k. And you will find the vertex point, okay? Did you understand?
Yes, yes.
I hope that you are understanding,
Yes, teacher.
because there is no any comments from the others, and it's not simple topic, guys.
So teacher, h is x or
H is the x coordinate. For example, we have x and y, and let's say the vertex point is here. So h is this one and k is this one, okay? When you will find.
okay.
H you are finding for x coordinate, k you are finding for y coordinate, okay? So I'm trying to find the h here, which will be, and you're not helping to me,
16 times 3, 30.
16. So I have 2 minus 4, it's minus 2 plus 48 will be 46 over 16. You can do the
It will be
equations here if you can. Then your vertex point will be minus 1 over 4 and 46 over 16. Here I gave, you know, from my mind the numbers. Because of that you have these big and different numbers, but the important thing is to know how we are finding the vertex point. Okay?
So it will be 23 over 8.
Yes, 23 over 8 it will be, and you'll find here 23 over 8 what is, and here minus 1 over 4, and that one will be your vertex point. So to draw a graph of quadratic function, first step is to find the vertex point. Then here you have some questions to find the vertex point. Find the coordinates of the vertex point of each function, write the equation of the axis of symmetry, and determine the maximum or minimum value of the function. Now, firstly, we have vertex as h and k. These are the coordinates that is talking about. So h is, we said that minus b over 2a. What is, I'm writing this minus, what is b here in this function?
Minus 2 over 2 times 1.
Minus 2 over 2. This minus and this minus will be plus, so 2
And we will have 1.
1. So h is 1. To find k, I'm writing instead of x the h value. So it will be 1 square minus 2 times 1 minus 3 it will be. So this one is 1 minus 2 minus 3, and k will be minus 5 plus 1 minus 4. So our vertex point, the coordinates of vertex point is 1 and minus 4. Okay? Write the equation of the axis of symmetry. Now, what does it mean? I have the coordinate plane here. And as I said, h is for x-axis. So if 0 is here, and let's say 1 is here, for h, and k is minus 4 on y-axis it will be. So let's say minus 4 is here. So this point is the vertex point, guys.
Lowest point.
And this line that passes from the x coordinate of vertex point, this one is axis of symmetry. And how we can write this one? Equation. It says like in the question, write the equation of the axis of symmetry, because it is only one line that passes only from 1 in x-axis. This is x is equal to 1. This is the equation of axis of symmetry, okay? X is equal to 1 is the equation of axis of symmetry. It's okay, this one?
Why 1, teacher?
Because it passes from 1. Here it's 1, yes? It's a straight line that passes from 1.
But the lowest point of this will be minus 4.
And determine the maximum or minimum value of the function. So this function will be upwards or downwards?
Downwards.
Why downwards?
Because we have minus y. Well, the coordinate is minus y. The vertex is
Which coordinate is minus?
the y.
But for saying if the parabola is upwards or downwards, what we are looking? We are not looking
For the minus we look.
We are not looking for the coordinates of the vertex. What we had here, two cases. If A is positive or A is negative. A, the coefficient of x squared. So to say for the function, if it is for the parabola, if it is upwards or downwards, we are checking the A.
So this will be upwards because
this will be upwards, and the value, the vertex point will be the minimum value. Okay? So point is here, minimum value. And what will be the minimum value? Minus 4. Okay?
Teacher, what about the maximum point?
Here we don't have, it goes till infinity.
Okay, teacher. If it is plus, it is maximum. If
Yes.
it is minus, it is...
Yes. Now, I'm giving you time to find if we have time. Less than 1 minute we have.
Teacher, the
Yes, lesson will finish. Okay, try to find the vertex. I think that this one is solved in the book, but again, check how we are finding the vertex point of the other functions. And if you didn't understand next lesson, tell me again, okay?
Okay, teacher.
Teacher, which page is this?
Which page is this? Good question. It's last chapter. Let me see.